So, students, today I'm going to talk about electric power and the related calculations. Power P is equal to VI, that is voltage times current. How do we get this formula? So we know power is a rate of doing work, how fast a work is done or how slow a work is done. Now, what is the work? We are not talking about mechanical work. We are talking about the work done in related to electricity. So let's assume a resistor with resistance R and current I flowing through this. Let's say it is connected to a power source having battery with a potential difference V provided across it. It is this potential difference V which is responsible for the flow of charge. The potential difference V is responsible for the flow of charge Q. So charge flowing per unit time is current. Now this is the positive terminal, this is the negative terminal, and we say the electrons are moving from negative to positive in this direction. The charge is flowing. Now power is basically, this is the work done. This is the work done power is doing. What work? Moving the charge, which was not being done when the resistor or any load is not connected to any power supply, or you say battery or mains or anything. When you supply the potential difference, what does this voltage does? It supplies the potential difference across the resistor. Now the free electrons in this resistor, they starts getting drifted from one side to other side, because this voltage actually polarizes the ends of the potential, this resistor. So this end becomes positive and this end becomes negative. Now power is rate of doing work as we define the power in mechanical terms. Now W is V into what? See, V is work done in moving unit charge. So from this, W is equal to V into Q. So from this we get this is equal to V into Q by T, and Q by T is current, right? Power is voltage times current, and there's another expression for the power. Let's say I multiply this right side by R and I divide by R. So I get V into IR divided by R. This is equal to VI, but IR is V, so this is equal to V squared by R. I have one more expression for power. When current is not given, I can always find P as rate of work done, P as VI, P as V squared by R. Whatever expression I use, I always remember the unit of power is joule by second, and that is equal to, students, anyone can say joule by second is equal to?
Work done.
Correct. Joule by second is equal to watt. So somebody says you define 1 watt. You could say that 1 watt is the power when 1 joule of work is done in 1 second. All right. Now, students, there's another way In electrical engineering, we define power is equal to V into Y, means power consumed by an electrical device connected in a circuit is 1 watt when it carries a current of 1 ampere, and the potential difference across its end is equal to how much volt, students? 1 volt. Another way to define the power. Now, watt basically is a very small unit for power, as 1 joule of work done is very small. You should have a practical insight into how much work actually is equal to 1 joule. Think about this. Now we define the commercial unit of power. Commercial unit of power as what's written here, kilowatt hour. How it comes? Kilowatt hour. Let's see how we reached here. Now, see that, students, electrical energy is basically power times time. Power times time. How? Well, power is rate of doing work, W by T, into T is equal to W. This is work done. Work done is energy. Unit of work done is joule. Unit of energy is also joule. So electrical energy is power times time. Now, this can be equal to, in SI units, power's unit is watt into second, or very small unit. So let's say watt hour. What is the meaning of watt hour? Watt hour is not power. Watt is power. Watt hour is electrical energy consumed by the device in case 1 watt power is used for 1 hour. Once again, electrical energy consumed or dissipated could be termed as watt hour when the electrical device uses 1 watt of power for 1 hour. All right. But then again, watt hour is also small unit of electrical energy. Now, we define a bigger unit of commercial unit of power, that is kilowatt hour. Kilowatt hour. Now, again think, students, will it be right to say that kilowatt hour is power or electrical energy? No, this is the power, kilowatt. Power is being divided by time, multiplied by time. So this is electrical energy. So on our meter, electrical meter installed in our home, I'm talking about domestic meters or even commercial meters also. See here, the reading is there. On the basis of this reading, we get our electricity bill every month at the rate of ₹4 or ₹5 per unit. And ironically, Punjab, which is producing electricity in Bhakra Nangal Dam, people here are charged 10 rupees per unit. What is this unit? The unit is electrical kilowatt hour. This is the unit of electrical energy consumed. So let's define kilowatt hour. A kilowatt hour is basically the electrical energy consumed electrical energy used by us in houses or by electrical devices when 1 kilowatt, that is 1000 watt power, is used for how much time? 3600 seconds, or you say 1 hour. So this is 1 kilowatt hour. Now 1 kilowatt hour, as we have understood that this is not power, this is energy. So energy is always equal to joules. So let's see, this 1 kilowatt hour is equal to how many joules? All right. So 1 kilowatt hour is equal to 1000 watt into 1 hour is, now in joule, the time must be not in minutes or hours, but it should be in seconds. 3600 seconds. Well, that is equal to 3.6 into 10 raised to power 6 joules. Again, watt into second. Watt is joule by second into second is equal to joule. So electric kilowatt hour is basically the electrical energy consumed when the electrical devices in the house which are rated at 1 kilowatt, they work for 1 hour. Now see guys, let's say in a house we have a fan, let's say 2 fans, 4 bulbs, it's a small house maybe, 1 AC, 1 fridge, all right, maybe something else, fine. So let's calculate how much kilowatt hour, how much units electricity comes for a month, or how much bill will come for a month, how much money they have to pay when 2 fans are working, 4 bulbs, 1 AC, and 1 fridge is working. Now, practically, let's say the AC is around 2 kilowatt, and a AC can maximum work in a house, let's say maybe 10 hours. So people are not very lazy in that house, let's say. It works for 10 hours, 8 hours and maybe 7 hours in the night, 3 hours in the daytime. 4 bulbs, all right, again, let's say they work for 4 hours. And the bulbs are, let's say 20 watt each. 2 fans, let's say this is 200 watt each, maybe 100 watt. And they work for, let's say, 10 hours in a day. Approximation. 1 fridge, let's say this is 1000 watt power consumed. This is the rating of every electrical device. It's written on the back side. And let's say, well, it works day and night, people are very wise in the house. They don't keep hot dishes so that the compressor will work more. Let's say, it works for roughly 16 hours. They switch it off for 8 hours. Maybe 20 hours, 4 hours is not working practically. So we want to calculate how much bill will come for a month. So first we want to calculate that in one day, by all these electrical devices, how much units are being consumed. Units means how much kilowatt hour energy is being consumed. All right. So see that guys, let's first calculate the watt of all the electrical devices. So we have 2 fans, 1 fan is 200 watt into 2. All right guys. Okay. Now this works for 10 hours. This works for 10 hours. So 1 kilowatt hour is the 1 unit consumed when 1 kilowatt thing works for 1 hour. Now it's like 200 watt into 2, that means 400 watt is being used for 10 hours. It's like saying 4,000 watt is being used for 1 hour. It's same. Or you can say, now if I convert this into kilowatt, I can say 4 kilowatt hour. So 4 units. Two fans will consume 4 units in a day. Now 4 bulbs. Now every bulb is 20 watt. Now 20 watt into 4 bulbs. So it's like 80 watts. Only 80 watts when all the 4 bulbs together work. Now it's only for 4 hours. 4 hours. So this becomes 320 watt hour. I want to convert into kilowatt, so it will be 0.32 kilowatt hour. So it's like just 0.32 units. See, 4 bulbs. This is the advantage of using, nowadays bulbs. They are like, like the wattage is very less as compared to previous bulb. It used to be, if you remember, it used to be 100 watt bulb. Fine. So one AC, well, it's working for 10 hours, so you can very well do it. One AC, 2 kilowatt, 2 kilowatt into 10 hours. Very simply, you can say in one day, can you tell students how many units it will consume in one day? Anyone can say? So it's like 2 into 10, it's like 20 kilowatt hour. And 1 kilowatt hour is 1 unit. So this is 20 units. So it will consume 20 units of electricity in one day. We're talking about one day, and we're simply going to multiply number of units of one day into 30 days maybe. So one fridge, 1000 hours, 1000 watt into 20 hours. So 1000 watt is 1 kilowatt into 20 hours. So this is equal to 20 kilowatt hours. So this will consume, again, it works for 20 units, right? So it will be correct. Again, 20 units this fridge will consume. It's coming more. I think maybe the watt of fridge is less. Maybe 400 or 500. So I've calculated it more. You can just check it and recalculate. If you want to make anyway, this is assumption. So total number of units consumed is 20, 20, 40, 44. So it's 44.32 in a day into 30 in a month. And what is the rate? Let's say we are in Punjab, so it's like highest 10 rupees. So this will be your bill for a month. So approximately, if you take this as 45 into 300, so this is equal to 00. So you'll have 13,500 rupees bill in a month. So it's a big amount of money. So what do you need to do? One thing, we have done a mistake. I think this must be low, and you need to operate AC maybe for 5 hours, so it will be less. So all these things, students, once you know, you can calculate. This is all about electrical power and electrical energy. Thank you very much.